Welcome to this tutorial on the local orchestration in EDGELESS, and in particular we will be focusing on the migration of functions. I am Claudio Cicconetti from the National Research Council in Italy, and I am the technical manager of the project. This is an overview of the components that will be showcased in the tutorial. We have an EDGELESS controller, icon, which provides an interface to the application developer to create workflows, which are the applications in EDGELESS made of functions. These functions are then sent to the EDGELESS orchestrator, which is in charge of managing the resources of the computing infrastructures, which are identified as nodes. In this tutorial, we will use two nodes, both running on embedded devices. One will be an NVIDIA Jetson, and the other one will be a Raspberry Pi. The orchestrator, the e-ORC, will proxy its internal status on an in-memory database, and in this tutorial we use Redis. This status information will so made available to the infrastructure developer, which will be able to watch the usage of resources and the current allocation of functions. Please note that the orchestrator at the moment only has a very basic policy to schedule the functions that are to be deployed on the nodes. And in particular, we will be using a simple round-robin policy, so that one function will be assigned to one node and the other function to the other node, regardless of the function characteristics and the node characteristics. However, the infradev will be able, based on the current status of the orchestration domain, to send migration intents to the EDGELESS orchestrator, again via this Redis in the middle. Note that the infradev operation with the system is totally decoupled from the EDGELESS component, since it is only interacting via this in-memory database in the middle. This allows for maximum flexibility. Let's now put this into action. So first, we will start the EDGELESS controller and the EDGELESS orchestrator. EDGELESS control. EDGELESS controller, sorry, that was the wrong machine, and the EDGELESS orchestrator, which are now running. Now we start the two nodes on the embedded devices by invoking the EDGELESS node on the NVIDIA Jetson on the left and on the Raspberry Pi on the right. As you can see, when we started the node, the EDGELESS controller noticed and wrote some log directives, while the EDGELESS controller on the left does not know anything about it, because the EDGELESS controller only interacts with the EDGELESS orchestrator without knowing the inner details of the orchestration domain that is being managed. Now, if we go from the point of view of the infrastructure developer, we can watch the status. So on this shell, I will open a proxy command line interface, which will allow access to the Redis in between the EDGELESS orchestrator and the infradev. And in particular, we will be showing in this shell the capabilities of the node. As we can see, there are three nodes. So the two nodes, the one ending with 001 and 002 in data identifiers, are the Jetson and NVIDIA and in the Raspberry Pi. The other node, which as you can see has 0 CPUs, it's only a virtual node that is running inside the EDGELESS orchestrator for internal purposes, which are not covered by this tutorial. By using a similar command, we can ask the proxy to watch what is the current health of the node. And again, the first one is the virtual one, which we are not interested into. The other one, 001 and 002, are the Raspberry and the Jetson. And in particular, the CPU usage is very low because they are doing basically nothing at the moment. And in the third shell, we will be watching the functions. So at the moment, we have 0 functions because the system has just started. And in fact, the window will be empty. At this point, we have everything we need in place, and it's possible for the app dev to create a new application or workflow. This is done by the use of the command line interface of EDGELESS, in which we issue the command workflow start, and we have to provide a JSON specification of the workflow. For this tutorial, we don't need the details of the workflow. In particular, this workflow will just run some matrix multiplication operations just to load a bit the nodes. So when we issue the first command to start the workflow, we see that something has happened. So this the workflow contains a single function identified by this long number, which was mapped to the 002 device. The 002 device is the Raspberry Pi. We can see it from the amount of memory and the other CPU characteristics on the bottom left shell. And we see, in fact, that the 002 CPU load has increased as a result of the application running. If we start one more workflow, we see that the orchestrator will assign it to the other node because as it has been already said, it is using a simple round robin policy. So now we have two functions. One is assigned to the Raspberry 002 and one is assigned to the Jetson 001. And we can continue this for as many workflows as we like, and of course the load will increase on both nodes. At the moment, we have on average on the pretty low 2-3% on the Jetson, which is more powerful, and the 15-16 CPU load on the Raspberry Pi, which is less powerful. At this point, let us assume that we want to migrate some of the load from the Raspberry to the Jetson to better equalize the load among the two machines. How can we do that? Well, we can send an intent to the edges orchestrator via the Redis. So by using the proxy command line interface to add entries into the in-memory database sitting between the user and the orchestrator, we can, first we have to specify the URL, of course. And then we can issue the command intent migrate, and we have to specify the identifier of the function we want to migrate, which in this case we want to migrate away from the Raspberry. So we will pick, for instance, this one, the one ending with the B48, and then we specify the identifier of the Jetson. We issue the command. In a few seconds, we see that the mapping between the functions and the nodes has changed. Now the 001 has 3 function instances running, while the 002 node has only 1. And we can repeat this also for the other function, where we say that we also want to migrate the only function remaining on the Raspberry towards the NVIDIA Jetson. And at this point, all the functions are running onto the Jetson. And in fact, the Raspberry load is now 0 or close to 0, while the Jetson load has increased a bit. As you can imagine, our long-term idea would be to substitute this human intervention with an AI-based automated orchestration process, which can read the current status of the system via the Redis, take appropriate actions based on the history and prediction of how the future status of the system might evolve into, and then send intents to the edges orchestrator. Thank you very much for watching this tutorial.